My wonderful Master's Vessel students, we are back today. The subject we are going to learn today is chemistry, SS3. But the other class can also benefit from it. Our last lesson, or for some time now, we've been studying metals and its compound, and we are still on sodium. The last lesson we studied sodium hydroxide. We saw the methods used in producing sodium hydroxide, the Gossage method, and the electrolytic method. We talked about some of the uses of sodium hydroxide. Today we'll be looking at sodium trioxocarbonate 4. Sodium trioxocarbonate 4 is produced industrially using the solvent process. And there will be need for us to see the drawing of the solvent process. It will help in explaining it. As I'm drawing it, if you want to learn this thing well, you'll be drawing with me, because while you are doing it, you are learning how to draw it. Please draw with me, because it will help you to now know how to draw, instead of going to your textbook and you may not learn how to draw immediately. Therefore, it's better for you to draw with me. This is the solver process. The raw materials that you require to make sodium trioxocarbonate for are mainly ammonical brine. Ammonical brine means that brine is sodium chloride. In ammonia, you now call it ammonical brine. These solutions are in water, so you can add water. Therefore, the raw material, you add the ammonical brine from the top. As the ammonical brine is coming down, the reaction occurs, and then CO2 joins it from below. When you have formed that, you have ammonical brine, which is these two compounds. Ammonia and sodium chloride, concentrated sodium chloride, is called brine. Then water, because they are mixed in water. Then CO2 that comes from down here, it will give you sodium hydrogen trioxocarbonate 4 and ammonium chloride. When you have formed this sodium hydrogen trioxocarbonate 4 and ammonium chloride, you will now heat this sodium hydrogen trioxocarbonate 4 to give you sodium trioxocarbonate 4. The important thing you should know here is this equation written down here. This two is the ammonical brine. And I've explained what ammonical brine is. I've said that ammonical brine is sodium chloride dissolved in aqueous ammonia. That is ammonical brine. That ammonical brine reacts with CO2 to give you sodium hydrogen trioxocarbonate 4 and ammonium chloride. Then the sodium hydrogen trioxocarbonate 4 is heated to give you the sodium trioxocarbonate 4. You can, this one becomes your equation 1. Then this one becomes your equation 2. This is the compound you want to produce. This is the compound you want to produce. But there is something that happened in this solver process. It's an economic process. If you look at what we have done, you see that the raw materials here are ammonia, sodium chloride, and CO2. But this CO2 and ammonia can be regenerated. It can be regenerated. Therefore, you have this ammonium chloride. The ammonium chloride reacts with calcium hydroxide to give you ammonia plus calcium chloride plus water. You can see that from what you have done, you have regenerated ammonia, which you can reuse again. You have regenerated ammonia, which you can reuse again. The only byproduct that is not very useful is this calcium chloride, but you have regenerated ammonia, which you can reduce again. Then we'll look at another equation. Another thing you will know that the CO2 you use here is gotten from calcium trioxocarbonate 4. When you heat it, it will give you CaO, calcium oxide plus CO2. You now use this CO2 as your raw material, then you know that you are still having calcium oxide. This calcium oxide is not useless. This calcium oxide now is not useless. You now dissolve it in water to give you calcium hydroxide. This calcium hydroxide, you reuse it in this particular point. For you see that they may ask you, why is solvent process economical? Your answer there is that solvent process is economical because most of the raw material is regenerated and it can be recycled back. Let me explain what I have said. Maybe it will equally be helpful. Remember that I said that some of the raw materials you use in producing sodium trioxocarbonate 4 are ammonia. In this case, we can say calcium trioxocarbonate 4. This calcium trioxocarbonate 4 is what gives us CO2. Then we have which one again? We have sodium, that is brine, sodium chloride. We have sodium chloride. Water, most times we don't regard it as raw material, but because it's always used in very high quantity in industrial process. Therefore, most of the time, we don't regard it as a raw material. Therefore, these are the raw materials you use. You discover this raw material I've written down ammonia with sodium chloride is what you call ammonical brine. Then the calcium trioxocarbonate 4 gives you the CO2. The ammonical brine reacts with CO2 to give you sodium hydrogen trioxocarbonate 4 and ammonium chloride. Then the sodium hydrogen trioxocarbonate 4, when you heat it, it will give you the product you are looking for, which is sodium trioxocarbonate 4. You discover that the ammonium chloride, if you react it with calcium hydroxide, you will recover ammonia, which you've recovered ammonia, which is one of the raw material you are using here. Then you saw that the calcium trioxocarbonate 4, when you heat it, it will give you calcium oxide and CO2. The CO2 is the raw material which you are using here. And how do we get it back again? You are getting your CO2 here. But when you get your CO2, calcium oxide will still be remaining there. This calcium oxide, when you dissolve it in water, it will give you calcium hydroxide, which you use to recover your ammonia. Therefore, when you look at it, you see how the solvent process is economical. Look at what I've just written here. You can write it down, but I've explained it. I say the solvent process is economical as CO2 and ammonia produced in the above equations are recycled. Also, calcium oxide produced from limestone is slaked to form calcium hydroxide. Therefore, you can see how you can recycle them. Let me recast what I have just said. I said that you produce sodium trioxocarbonate 4 by a reaction in solvent process. And that reaction in solvent process, the raw material used there are ammonia, brine, which is sodium chloride, then CO2 from calcium trioxocarbonate 4. And I said that the ammonium brine comes from the top, while the CO2 comes from below. When they react together, it will produce sodium hydrogen trioxocarbonate 4 and ammonium chloride. And I said that the sodium hydrogen trioxocarbonate 4, when you heat it, it will produce your sodium trioxocarbonate 4 and water. Then we talked about the ammonium chloride that you produce. That ammonium chloride that you produce, you react it with calcium hydroxide to produce again ammonia, which you will reuse later on. These are the reasons why it is economical. This solvent process sometimes maybe let me summarize the equations, because sometimes they will ask you to do it by equation. Therefore, let me summarize the equations that are involved in solvent process. You can copy it from here. The equation is 1. Ammonia reacting with sodium chloride. Reacting with water, reacting with CO2, it will give you ammonium chloride plus sodium hydrogen trioxocarbonate 4. Aqueous solid. Sodium hydrogen trioxocarbonate 4 is slightly soluble in water, therefore it comes out as a solid. You can regard this in as your equation 1. Then your sodium hydrogen trioxocarbonate 4, when you heat it, you have sodium trioxocarbonate 4 plus water. Let's check whether the equation is balanced. Sodium is 2, sodium is 2. Carbon is sodium is 2, sodium is 2. Let's see. All right, plus CO2. This is the second equation, equation 2. For you've seen that we have regenerated CO2. The next thing is the ammonium chloride reacting with calcium hydroxide. It will give you calcium chloride aqueous plus ammonia gas plus water. These ones that I'm circling are the regeneration of the raw material. You can regard this one as equation 3. You can see from equation 2, you have regenerated CO2. From equation 3, you have regenerated ammonia. Remember this equation also, CaCO3. When you heat it, you have your CaO plus, that is calcium oxide plus CO2. You can regard this as equation 4. Or you put the equation, maybe equation 2 up before you write the other ones. For you see again, there is another equation. The other equation is calcium oxide plus water. That will give you calcium hydroxide. Remember that that will give you calcium hydroxide, which you make use of in equation 3. Therefore, there are 5 equations which you can use to explain solvent process without writing them in clauses, without writing any English. These equations, these 5 equations that I've written down are the equations that are involved in solvent process. Most times in the exam, that is what they will ask you. If you can put, let me rearrange this. This equation can be called equation 2. Or possibly, let it be equation 1. Therefore, this one becomes 2, this one becomes 3, this one becomes 4, this one becomes 5. Therefore, you have CaCO3. When you heat it, you have calcium oxide plus CO2. Therefore, you generate the CO2 here and use it in the solvent process. Then, I think it's better arranged this way. You generate CO2 here, then use it as your raw material here instead of that, then you get this. For let's look at properties of sodium trioxocarbonate 4. Let's look at the properties. Please listen very well so that I can just dictate it for you. 1. Sodium trioxocarbonate 4 is an anhydrous white solid. Sodium trioxocarbonate 4 is an anhydrous white solid. Two, the hydrated form of sodium trioxocarbonate 4 is called washing soda. The hydrated sodium trioxocarbonate 4, which is Na2CO3 10, which is sodium trioxocarbonate 4 decahydrate. And the other name for it is washing soda. I said that the hydrated sodium trioxocarbonate 4 is colorless and crystalline. Remember that the one that is not hydrated is anhydrous. Anhydrous means that it's powdery. Crystalline means that it's in granules. Then 3. Both the anhydrous and hydrated form of sodium trioxocarbonate 4 dissolves in water, though that the hydrated form is more soluble in water. Number 4, aqueous solution of both anhydrous and hydrated sodium triosocarbonate 4 turns red litmus blue, which means it's an alkaline salt. It turns red litmus blue. Then 5, crystalline sodium triosocarbonate 4, when heated, give anhydrous sodium triosocarbonate 4. Crystalline, that is Na2CO3. When heated, remember that this particular equation can be in both chemical and physical properties. Therefore, when you heat it, it will lose the 10 moles of water of crystallization to give you Na2CO3, which is the anhydrous one, plus 10 H2O. But anhydrous form of sodium triosocarbonate 4 is stable to heat. It's not decomposed on heating. Or you can regard it as 6. Anhydrous, that is Na2CO2, anhydrous sodium triosocarbonate 4 is stable to heat. It's not decomposed on heating. And you should know that the group 1 triosocarbonate does not decompose on heating, which means that potassium triosocarbonate 4 also does not decompose on heating. All right, let's look at chemical properties of sodium triosocarbonate. Let's look at the chemical properties of sodium triosocarbonate 4. Chemical properties. I'll dictate, but the equations I'll write on the board. Hydrolysis. Hydrolysis is addition of water. Na2CO3 hydrolyzes in water. NaCO3, that is sodium triosocarbonate 4, hydrolyzes in water to form an alkaline solution. I know you should know the reason why it forms an alkaline solution is because it is formed from a strong base and weak acid. It's formed from a strong base and weak acid. Therefore, your Na2CO3, when it hydrolyzes in water, will give you NaOH plus H2CO3, aqueous. This is a strong base. This one is a weak acid. I said that the sodium triosocarbonate 4 and hydrosodium triosocarbonate 4 hydrolyzes in water to form an alkaline solution. And I've given you the reason because it is formed from strong base and weak acid. Then the second one, number 2, is reaction with acid. Reaction with acid. You will discover that sodium trioxocarbonate 4 is actually a salt. But because of the first reaction, you see that it forms an alkaline solution. You see it acting as if it's a base. Therefore, reaction with acid. Sodium trioxocarbonate 4 reacts with dilute acid to liberate CO2. It reacts with acid to liberate CO2. You know that ordinarily what should react with an acid should be a base. But this is a salt. But because it behaves like a base, it's giving you a reaction with acid. Say number 2. Sodium trioxocarbonate 4 reacts with acid to liberate CO2. For you have Na2CO3 plus HCl to give you NaCl aqueous plus water plus CO2 gas. You can see that it's giving you a salt, water, and CO2. If it's ordinary alkalis, it will give you salt and water only. But reaction of sodium trioxocarbonate 4 gives you salt, water, and CO2. And I've told you the reason why it's giving you a result similar to that of alkalis. I've said this because an aqueous solution of the salt is alkaline. Therefore, it behaves as if it's a base, but actually it's a salt. Then number 3, precipitating agent. Precipitating agent. Precipitating agent. Anhydrous sodium trioxocarbonate 4 precipitate insoluble trioxocarbonate and hydroxides. That is to say, when anhydrous sodium trioxocarbonate 4 when it combines with another salt, it precipitates trioxocarbonate. For example, you have sodium trioxocarbonate 4 aqueous plus calcium to give you calcium trioxocarbonate 4 plus sodium tetraoxosulfate 6. This is a precipitate. Calcium trioxocarbonate 4 is a precipitate. Then let's look at uses of sodium trioxocarbonate 4. Uses of sodium trioxocarbonate 4. Let me recast what we have done under chemical properties of sodium trioxocarbonate 4. We said the first one is hydrolysis. That is reaction of sodium trioxocarbonate 4 with water. And we say that when you react with water, it forms an alkaline solution. Say that it will form an alkaline solution. And I said that it forms an alkaline solution because the salt is formed from strong base, weak acid. Then number 2, reaction with acid. I said that when sodium trioxocarbonate 4 reacts with dilute acid, it will liberate CO2 with the formation of sodium salt and water. It will liberate CO2 with the formation of salt and water. And I said if you look at this second reaction, you see that the salt is behaving as if it's a base. And the reason why it's behaving as if it's a base is because when you dissolve that salt in water, it will give you an alkaline solution. Therefore, the reactions of base, it will equally react the same way bases react. All right, the third one is precipitating agent. You can use sodium trioxocarbonate to precipitate another salt from an aqueous salt. And we saw the example where sodium trioxocarbonate 4 is used to precipitate out calcium trioxocarbonate 4 from calcium tetraoxosulfate 6. Therefore, let's look at uses of sodium trioxocarbonate 4. Uses. Uses of sodium trioxocarbonate 4. Most of these uses, you already know them because we have done chemical industry. And when we were doing chemical industry, we came across some of these uses. Therefore, sodium trioxocarbonate 4 is used in manufacture of sodium hydroxide. We've just studied that in when we were doing production of sodium hydroxide. The last lesson. Sodium trioxocarbonate 4 is also used in production of glass. It's also used in production of soap as a filler. When you produce some of these products, you need to add something that will give weight to it. Therefore, after producing your soap, you add sodium trioxocarbonate 4 to give it weight. So that you see, if somebody brings soap now that is maybe 30 grams, that one doesn't contain sodium trioxocarbonate 4, and another one 90 grams, and he's selling it at the same price, you will not agree to buy. Therefore, you use it as a binder in soap making and some other things you produce. You use it to give it weight. Sorry, not as a binder, but as a filler. 2, use in softening of water. We have done water treatment, and we saw that you can use sodium trioxocarbonate 4 to remove hardness in water. Number 3, use in acid-base titration. Today we have seen how sodium trioxocarbonate 4 can react with acid, which means it can be used in acid-base titration, where the sodium trioxocarbonate 4 is acting as a base. Instead of using sodium hydroxide or potassium hydroxide in doing the titration, you can use sodium trioxocarbonate 4 to do the titration. Number 4, in the manufacture of paper. Number 5, in the treatment of acid splash on skin. In the treatment of acid splash. When acid pours on your body, maybe you are doing an experiment in the laboratory. You are doing an experiment in the laboratory. Perhaps you are not very careful. Concentrated acid pours on your skin. As you use good quantity of water to wash it off, you will not stop at that. You will now use a weak base. This sodium trioxocarbonate 4 is acting as a weak base. Even though it's not a base, it's acting as a weak base. because you are not going to use a solution of KOH or sodium hydroxide. These two are strong alkalis or bases. If you use it, it's equally corrosive to your skin. Therefore, the best thing you will now use is a weak base to pour on the skin. It's used in removing. Therefore, when you have acid splash, don't use KOH or sodium hydroxide to pour it and feel that you want to neutralize it. Both of them are corrosive. After using water to wash it off, you now spray the place with sodium trioxocarbonate 4. All right, let's just mention this and we'll go from here. Let's look at sodium hydrogen trioxocarbonate. Another compound, sodium hydrogen trioxocarbonate 4. Remember that we have done sodium hydroxide, we have done sodium trioxocarbonate 4, we are now doing sodium hydrogen trioxocarbonate 4. If you look at our solvent process, you will see that when you react, the reaction between ammonium brine and CO2 and water gives you sodium hydrogen trioxocarbonate and ammonium chloride. Therefore, assuming that you are producing sodium hydrogen trioxocarbonate 4, you will stop at that. You will not need to go and heat it to produce your sodium trioxocarbonate 4. Therefore, you can use solvent process to produce sodium hydrogen trioxocarbonate 4 by the reaction between ammonia. We've done it before. Ammonia reacting with sodium chloride, reacting with water, which is usually there, plus CO2. We say that is going to give you ammonium chloride aqueous plus sodium hydrogen trioxocarbonate 4. This sodium hydrogen trioxocarbonate 4 is slightly soluble. Therefore, you can crystallize it out and wash it. You have produced your sodium hydrogen trioxocarbonate 4 from this experiment. Because what you will now do is to filter this thing out, wash it with water to remove excess reactant, and then dry it. You have produced your sodium hydrogen trioxocarbonate 4. Let me mention here that this sodium hydrogen trioxocarbonate 4 is also regarded as a baking powder. It doesn't mean that the powder, but the main constituent of it, the one that causes it to be used as a baking powder, is sodium hydrogen trioxocarbonate 4. Just like I mentioned before, you can have filler, the thing that you use to give it weight, you add it. But the actual reaction, what you are using it for, contains essentially sodium hydrogen trioxocarbonate 4. Another name of this sodium hydrogen trioxocarbonate 4 is called baking soda. This baking soda, I will mention it before, but let me just mention again. Baking soda is used in production of most of the things we bake. The essence of it is that when you heat this sodium hydrogen trioxocarbonate 4, it will give you CO2, and the CO2, since it's a gas, if it's in this bulk, it will cause the flour to rise. Therefore, the intention for the addition of baking powder is to cause it to rise, even though yeast is equally there, but the essence is to cause the flour to rise. Then laboratory preparation of, we've talked about the industrial preparation, which is through the solvent process. Let's look at laboratory preparation. Remember I said that Sodium hydrogen trioxocarbonate 4 is produced industrially using solvent process. If you use solvent process, you produce your sodium hydrogen trioxocarbonate 4 and ammonium chloride. And from that solution, since sodium hydrogen trioxocarbonate 4 is almost insoluble in water, you can filter it out, wash it, and dry it. And then the ammonium chloride is a filtrate, which you can now filter out. Let's look at how you prepare it in the laboratory. In the laboratory, you just produce it by bubbling CO2 in aqueous sodium trioxocarbonate 4. N2CO3 aqueous because it contains water plus CO2. If you bubble it, you have NaHCO3 for you have produced your sodium hydrogen trioxocarbonate 4 by that method. Since we have discussed industrial preparation, let's look at the physical properties. Physical properties. PPT's properties. Physical properties. 1. It is a white crystalline solid. It is a white crystalline solid. I've already said that the other name for it is baking powder. 2. Is slightly soluble in water. When they say that something is slightly soluble in water, it means that it's almost insoluble. The only thing is that some part of it can be soluble. It is because it's slightly soluble in water. That's why you can remove it out by filtration. Then chemical properties. The two properties are, number 1, is a white crystalline solid. Number 2 is slightly soluble in water. Let's now look at chemical properties. Chemical properties. 1. Sodium hydrogen trioxocarbonate 4 decomposes on heating. We've said it before. It decomposes on heating. NaHCO3, if you heat it, you have Na2CO3 plus water plus CO2 gas. Number 2, it reacts with acid to liberate CO2. It reacts with acid to liberate CO2. Sodium hydrogen trioxocarbonate 4 reacts with HCl to give you sodium chloride aqueous plus CO2 plus water. Then number 3, reaction with water. Sodium hydrogen trioxocarbonate 4 reacts with or is hydrolyzed in water to form sodium hydroxide and trioxocarbonate 4 acid. Therefore, it forms an alkaline solution. And the reason why it forms an alkaline solution is because it is formed from a strong base and weak acid. The same reason that I gave you before. Let's look at uses of sodium hydrogen trioxocarbonate 4 And that is where we are going to end the lesson. Uses. 1. Is used in production of sodium trioxocarbonate 4. It's used in production of anhydrous sodium trioxocarbonate 4. 2. It's used to produce baking powder. 3. It's used to produce hair salt for indigestion caused by stomach acid. It's used to produce hair salt for indigestion caused by stomach acid. The reason is not far-fetched. We have seen that it's an alkaline salt. When you dissolve it in water, it will give you an alkaline solution. An alkaline solution will have a high pH, and that high pH will help in reducing the acidity of the stomach acid. It will try to neutralize the stomach acid, thereby helping you for your system, your bowel to move better so that you won't have indigestion. Then 4 is used as fire extinguisher. You see that when you heat it, it will produce CO2, and CO2 is used to fight fire. For that is the uses of sodium hydrogen trioxocarbonate 4. We have seen that is the end of the lesson for sodium. That is the end of the lesson for sodium. Remember that when we did sodium, first and foremost, we did sodium as a metal. We now look at the compounds of sodium, and the ones we treated were sodium hydroxide, sodium trioxocarbonate 4, and sodium hydrogen trioxocarbonate 4. Let's look at our assignment. Please copy fast. 1. Sodium trioxocarbonate 4 is produced industrially. A. Name the process. B. List the raw materials used for production of Na2CO3. C. Using equations only. Show the steps involved in the production of sodium trioxocarbonate 4. D. Name the only waste products from the process. 2. Explain how sodium hydrogen trioxocarbonate 4 is produced industrially. Let me go through the question again. 1. Sodium trioxocarbonate 4 is produced industrially. A. Name the process. B. List the raw materials used for the production of sodium trioxocarbonate 4. C. Using equation only, show the steps involved in the production of sodium trioxocarbonate 4. D. Name the only waste product from the process. Number 2, explain how sodium hydrogen trioxocarbonate 4 is produced industrially. Thank you for the attention. God bless you. Stay safe. I still remain your chemistry teacher, Mr. Chidube Odemenam. Bye.